So I'm going to try the problems fresh. Never tried them. So we'll do it now and we'll see. So, and then if needed, we'll look at the solution. As I told you guys, you guys try the problems, and then after that you can look at the solutions. The solutions are there also. So there is problem number 1, and we are focusing on the number theory looking question. So take the question number also. So now we find all primes. Find primes they are same. Both things are same. I just sent it again. Plus. Okay. This find primes P and Q such that this is a perfect square. So, yeah. Can anybody give examples? Right. That's an example. No. Yeah, I think let's try. So if you take P and Q equal to 2, is it a prime? Is it a perfect square? And then we have 28. Yes. So this is a perfect square. Oh, wonderful.
Yeah, if P is equal to Q, then it will always be 3 into P. The
Expression.
The integer will.
Oh, okay. So P equal to P implies, so if both are P, then
3P.
Oh, yeah, wonderful. Yes, obviously, right. Correct. That was easy. I didn't see it. So certainly P equal to Q works. Okay, any prime is not. It's not about primes in that. Let's focus on P not equal to. I suppose there's nothing to say. You just note down P equal to. Now we'll look at P not. So let us see.
I think it's.
Huh?
I think it's not possible.
Oh.
I don't think they exist.
Okay. So you guys are saying, 2 of you have said it doesn't. It's not possible. But let me just take a few examples. That's very good. So this is the benefit you've tried before. Very, very good. 9, and this is 55. So it's not doesn't work. Let me. So you're saying not possible. Okay. So maybe Nagesh, first you can tell me some reasons why you think it is not possible.
So you can write the expression as P plus Q the whole square plus 5PQ equal to A square.
Okay, A square.
So A will be root of the expression on the left side.
Okay. All right.
So for that, the inside part to be a perfect square, you need 5PQ to be a product of another perfect square and P plus Q the whole square, right?
No, I don't think so. Why? I mean, why? It might be, but why? I don't know.
Because
it's a sum, and sum of a square and a non-square could become a square.
No, the sum of a non-square and a square. That non-square part again should be a product of a square, a perfect square, and p plus q the whole square, right?
Why? No.
For example, like the 3p case, it has to be like p plus q the whole square into some perfect square, right?
Okay, so you're saying that this 5pq, okay, let's see. So you're saying that this 5pq is p plus q whole square times something.
Times another perfect square.
Another perfect square.
Yeah.
No, that is wrong.
Only then it will be a perfect square, right? Then the sum.
No. So see, let's see. If okay, let's assume that that happens. Okay, so let's assume that it is like this. Okay, let's assume that 5pq is like this. In that case, in fact, it will not be a perfect square, right? Because you can pull out the
one less than the perfect
square. It could be one less than a perfect square. This is sufficient. Yeah. So, but the point is that if 5pq is like this, then this is a perfect square. Then a is a then that implies that a is an integer. Okay. A is integer. But it's not necessary, right? It could happen in all sorts of mysterious ways. Why can it not happen in some other way? Is it necessary that it has to happen like this? I don't think so, right? So, for example, I'll give you an example. You take 16. You take 16, right? That is 4 square, right? And then you can add 3 square, and that gives you 5 square. But 3 square, the 3 square doesn't have 4 at all, right?
No, but 3 also doesn't have like 3 prime numbers, right? Like, at least.
Okay, but if there are 3 prime numbers, then why should it be like this? This is not a proof, right? You understand, right? I mean, if it is like this, then I say, okay, it works. And then you can get that it cannot be like this and so on. But that I mean, this does not imply that it has to be like this. This does not imply that. Right? You could get it in many ways. Right? So I don't agree with this. Unless you prove. Unless you prove that, it's not implied. Why this should imply that 5pq should be in that special way? You have to prove that from here it implies, and we have not said that. You have just said that it should be like that, but it doesn't follow from this. Or taking the
converse. But even otherwise 5pq, it will never be like another square, right? Like 3 square.
Yes, that is fine. But then, so 5pq doesn't have a square. I agree, and doesn't have a square factor even. That's I agree. But that doesn't mean that this quantity cannot be a square. That's what I'm saying. It could still be a square in some other way. I understand. So what you are saying, that will never happen. But that doesn't mean that this will not be a square. Right. It could be in some other way also, with some mysterious way. There's some, right? So some of I understand in the end you will be right because there are no solutions, no more solutions maybe. So in the end, maybe it's correct. But without a proof, yeah, it's not correct. So Ishana, do you have any other reason? Any?
Sir, I had applied that primes are always of the form 6k plus minus 1 for primes greater than equal to 5.
Okay. Sorry, that's wrong. Okay. So how did you apply that? You just wrote P as like this and Q as like that, or?
It is 6n plus minus 1. So there are 3 cases possible. Either both P and Q are 6n plus 1 format, or both are of 6n minus 1, or 1 is plus, 1 is minus.
Whoa. Okay. Okay. So for those who don't know, this is very good. Yeah. So for those who don't know, try to prove that a prime is always 6k plus 1 or 6k minus 1. Obviously after 5. 5 is okay. 5 is also like that, but yeah, apart from 3, 2 and then so then Ishana, so in all cases you're getting it's a contradiction.
Yes.
So let's take this case and see if you're correct. So P and Q are 1 mod 6. So I'm using the mod language. You get comfortable with this. Okay. We have done this, so we should take advantage of this. So then you say that this expression will become something mod 6 like that. Okay. Let's see. So the P square is 1 mod 6, right? And 7 becomes 1 mod 6, and PQ is also 1. So, and then this is also 1. So, so then we are getting that this becomes 3 mod 6. So, right, so left hand side modulo 6, it becomes 3. So A square becomes 3 modulo 6. But why is that a problem? If you have done this, I don't see a problem with it being 3 mod 6.
Sir, I had first expanded it and then see if it's of a whole square formula.
Okay, so you went more into the thing. This is just the, yeah, okay. Because so can anybody give me we are not just solving the problem, but simultaneously just learning bits and pieces from it. Okay? So can anybody give an example of a square which is 3 mod 6? Any Aparna, you are there also, right? 3 mod 6. 9 is 3 mod 6, right? So just 3 mod 6 is not a problem, right? But so, Ishan is saying she put the thing and checked. So do you have the expression with you, Ishana? Can you tell me? Otherwise, we have to
Sir.
yes.
For both P and Q of 6K plus 1 format, I got that it should be like 36K square plus 36K2 square plus 9.
Wait,
So till here it
36
was of
36 K1 square plus K2 square. Okay.
plus
Then
9.
plus 9 in it in the 36 only.
No, not in it.
Okay.
Plus 54K plus 54K2.
K1 and K2. Okay. Plus. Okay.
Plus 252 K1 into K2.
Okay. K1. Right. So whenever you introduce K2, you should name the other one K1. Then there is it's not there. Okay. So this is all, I suppose.
Yeah.
So why is this a problem?
So for this to be a whole square, the only possible thing is 6K1 plus 6K2 plus 3 whole square. As A plus B plus C whole square formula is that only.
Oh, no. Again, no. It could become a square in more mysterious ways. See, that's the same conceptual error. Right? This does not, I mean, if it is like that, then you get a square, that's okay. Right? But again, it could become a square in more mysterious ways. That is the point. Right? I mean, just because if a number is not a square minus b square, it doesn't mean it's not factorizable. Something like that. Right? No, that is. But do you see the flaw? Right? I mean, so you are saying that this would be like some. So what did you say? This should be of the form K1 plus K2 plus 3 or what?
No, 6K1 plus 6K2 plus 3 whole square.
6 is right, yeah. Yes, I mean, if it is like this, then it's a square. But again, it could become a square in more mysterious ways. Because you see, it doesn't have to be a square for all K1 and K2. For some K1 and K2, it has to be a square. Right? So that's not a problem, no. Okay, it could become square in more mysterious ways. Do you see the logical problem, right? In your own,
Yes.
Everybody see that, yeah. It doesn't have to be like this. So then, yeah, what you can do is what you can do though is use this. So basically, suppose you knew that there were solutions, right? Then typically the solutions would look like this, and you could use them to find infinitely many solutions and whatnot, right? You could use, but unless it is, but this may not be all. But you can take that as an inspiration, and in the sense that you can see what this expression is compared to that, right? So if you compare it with this, then what is being left I suppose you may have calculated that. 36k1 square, 36k2 square, right, is oh, okay, yeah, sorry, yeah. 36k1 square, 36k2 square is there, 9 is there.
18 into k1 plus k2 is being left out.
18.
And 252 minus 72 k1 into k2.
Oh, k1 plus k2, k1 into k2. Okay. Yeah. So then you can do that and maybe see something, but I don't see anything. So I cannot say. Okay. No. No, so that's the remaining thing is is there a difference of squares? You can question and so on. But this looks very big now, so it doesn't look. Okay. So we are not. So Aparna, do you have any approach solution?
Sir, even I tried it, but I didn't get any solution. I mean, I couldn't complete the solution.
Okay. So all of us feel that there are no solutions, but we are not able to do, and so am I. I don't know how to do this. So let's see. So if we write this as p plus q whole square in general, p plus q whole square, then we get 5pq. Okay, this we already wrote. Then we get this, right? Okay. Then maybe we could say, so we can take the difference of squares, right? And you can do a plus b plus q. Okay, this. Now, what can we say from this? Yeah. Let's see. Okay. What can we say from this? Some idea, some different idea came. I'll try that. Okay. But what can we say from here? So you notice that you can say that P has to divide the right hand side. Is that right? Yeah. P has to divide the right hand side. So P will divide one of the factors. Does everybody agree? I mean, P will divide this or P will divide that. No, this may be a very silly, very simple thing, but do you agree with it? Do you know this?
Yes.
Right? That if P divides a product of two numbers, right, then P divides one of them. This is only happening because P is a prime. Does it happen for other numbers? Does it happen if P is not a prime?
Not necessarily.
Not necessarily. In fact, never. If P is not a prime, you can always find two numbers such that it divides that, but it doesn't divide. Because if P is not a prime, let's say it has two, let's say P is a product of two primes or something, right? Then you can always find a number, right? I mean, you can always find some number where this will not work. Okay. So for example, if I give you the number PQ, you can give me a number such that PQ will divide that number, but PQ will not divide any other. Well, you can just take PQ itself, right? And this will be the A, and take this as the A, this as the B. PQ doesn't divide any other. Anyway, that's a silly one. But this is a very fundamental thing, and this is the correct definition of prime. Rather than it doesn't have any prime any other more prime factors other than itself. This is a better definition for many reasons. Anyways, coming to the point. This let's take the first case. The second case is remaining. We'll do it. We'll have to do the second case, but we get this first case. So this implies that also I mean you could assume that P is bigger than Q. No harm in doing that, right? P is bigger than Q. Any ideas from here? It means P must divide A plus Q. right? So are we getting anything? We are getting that Q is congruent to minus or A is congruent to minus Q mod P. That's what we are getting, right? So Q, I mean, P divides A plus Q. Okay, so Q will leave a, when A will leave a remainder minus Q. Just a second. Just a second. Okay. But this doesn't seem to help. Right? So this A is minus Q mod P. Okay. So if you now take both sides, so this encourages us to take both sides modulo P, check the remainders modulo P. So this A will be Q square modulo P, but then the left hand side is also Q square modulo P, right? The P square and 7PQ vanish. So this is not useful at all. It's not going anywhere. Seems like that. Array, what is happening? Some ads are coming. Some ads for blocking other ads. Okay, strange. So this doesn't seem to work. No. Yeah, so it seems like this is not going anywhere. So, well, there is another approach. What I sense from this thing is obviously first you have to get the sense that there are no solutions. When P is not equal to Q, there are no solutions, right? But even then, oh, right. So the other thing that I'm thinking is why this will not be a perfect square is that this thing seems very close to a square, right? So look at on the number line, right? There is this P plus Q whole square. Where is the next square? It is P plus Q plus 1 whole square. Agree? Right. And the next one is P plus Q plus 2 whole square and so on. Okay. If you can show that this number, this left hand side is between two perfect squares, you can show that it is somewhere in between these two, then it cannot be a square. Okay. All right. So that is, maybe we can try that. Don't know if it will work. So let's expand this. So this again, this is like, I know I'm not saying it's P plus Q plus 1 whole square. I'm not saying it has to be that. I'm just trying to compare it with that sort of. And I'm trying to prove it is not possible, right? So let's just see. 2PQ plus P, plus 2P plus 2Q. That's just expanded. Is it correct? It is not correct. It is this. What should you do now? Now, 2 minutes to think. You're all thinking, but does everybody get the idea of what I'm trying to say here? Right? For instance, just give me I'll give you a quick problem, right? Show that n square plus 2n is never a perfect square when n is positive. How would you show? Well, you'll just say that, well, look, this is between n square and this is less than n square plus n plus 1 whole square. There's no way it can be a perfect square. Okay. That is what I'm trying to do. So now your job is to compare this thing with this thing and try to show that that thing is lesser than this, right? Let's see, and if it is lesser. Think. Is it less? I'm just doing. No, so it is not. It's not less. Doesn't seem to be. It's already like this 7 PQ. Is this less than? It is certainly not true, right? It is not true that it is less than this. Okay, because 5 PQ doesn't have to be less than 2P plus 2Q plus 1, even if P is not equal to Q. Right? So you could say, oh, Q is at least P plus 2, but still it's not 5 PQ. It's usually bigger. Yeah, so this will not work. So now what should we do? So basically, what this tells us that P plus Q plus 1 can be a candidate. So this is like the RMO questions are like this. Right? Cannot do it in one shot. So the point is that P plus Q plus 1 could be a candidate. So we have to show that it cannot be. We have to show that this is not possible. Okay, which is maybe easy to do, right? Okay, we already expanded this and took the difference. So what was the final difference? Maybe we can just look at that and show that this is not a perfect square. The difference was 5PQ minus 2P minus 2Q minus 1. Okay, this has to be equal to 0, right? This has to be equal to 0, right? If this is P plus Q plus 1 whole square, then this has to be equal to 0.
Yeah.
Right? But that's possible. So can this be 0? Can this 5PQ plus 2Q plus minus 2Q minus, can this be 0? It cannot be 0, right? It's just impossible for it to be 0, right? Just look at this quantity, right? It cannot be 0. In fact, this is bigger than P plus Q plus 1. That's what I'm saying. It cannot be 0 because simply because you can keep these terms. I mean, you can already feel that 5PQ is big enough, but still, you can just write this 2 minus 2Q plus, right? And all these are positive. All these are positive. Q is not 1. It's in fact positive, not even 0. Right? This is a positive. Cannot be 0. Okay. So is it clear? So it cannot be P plus Q plus 1 whole square because it is bigger than it. Simple. Any doubts? Please stop me. Okay. But this is like an RMO question. So we have to just. Also, I'm doing RMO question probably after many years. I mean, no, not while like this teaching so on, I do a little bit, but usually we do other kinds of questions. Anyway, so this is not possible. All right. So what's the next thing? Well, we move to the next thing. We forget this, right? And so we know that it is bigger than this. So that's fine. That's good. We move to the next thing, right? So we will try to show that it is either bigger than P plus Q plus 2 whole square. And you can kind of get the hint that you don't have to go too far. I mean, these numbers will soon become bigger than what we are given. Okay. So it's not infinite amount of work. This quantity. So either you show that this falls here or you show that it falls outside. right? And one of them has to be. So just compare it. Just please compare it and tell me. This is just 2. Oh, this is not working. I think that was wrong. Could go long. Uh, if it is equal, then it is this. Now, obviously, again, you can say that this cannot happen. It's bigger than that. You can try to prove it in the same. But the problem is that
3 PQ, right?
3 PQ.
3 PQ minus 4.
Is it 3?
Yeah, the minus is 2 PQ and 2.
2, and this is 7. No, this is 7.
No,
It
this is 5.
Oh, no, 5 is here, but overall it is 7.
Okay.
So this is 5. Yeah, so this is again bigger, but the.
Sir, I think it will be greater than P plus Q plus 2 the whole square.
Yes, it is greater than that. And the problem that I'm facing now is that it seems like this method is also not going to work, right? Because even if you do P plus 3, right, you don't know because this quantity is not growing. That is the problem. Check. This is not working. So these are primes. Right? No, this method is not working. I was thinking that, but no, this is wrong. This method doesn't works in a lot of problems. So you see, like it doesn't seem to work because you go to 3, 4, and it's same problem. You cannot really always say because that this PQ thing in this is not growing, and we cannot skip the squares in between. And if I take a k here, and obviously the k is, let's say the k is less than p, let's say. Otherwise it's done. K is bigger than p, then it will become bigger. But if this is the situation, then the problem is that you will have a k square, right? And you'll have 2k, right? There's no way to tell whether this can be 0 or like if k is this is the odd number and then k has to be odd, but then that's not good enough. 1 mod is no, it doesn't. Oh.
So for the 6K method that I was using, can I do the same thing to prove that like 6K plus 6K2 plus 3 whole square and 6k plus 6k2 plus 4 whole square, that this number will lie between them.
Okay, so okay, that's a very good thing. Yeah, because what I'm doing is sort of a wrong kind of thing, right? I'm basically looking at the wrong intervals, and what you are suggesting might be the right. So yeah, okay, yeah. So what was your intervals? Can you say again?
6k plus 6k2
6k1 plus 6k2
plus 3 whole square.
Okay.
And 6k1 plus 6k2 plus 4 whole square.
Yeah, but you will not get the advantage of taking the sixth and all here, right? In the sense that what you are just saying is this is p plus q plus 1 whole square, right? Right. I mean, comparing it with what I was doing, at least, right? This is that, and this is p plus q plus 2. I don't think so, because we already did sort of. We didn't get any.
Sir, if we use the fact that PQ will always be greater than P plus Q.
That is right, and that's maybe what we have to do. Something. No. Yeah. No, so so one approach, if this works out in the interval method, then you have to wisely figure out two intervals such that it is between them. Okay. So this doesn't look like a wise one. So you are saying that PQ is bigger than PQ is bigger than plus Q is. Let's see. So PQ is bigger than P plus Q. That's right. But also maybe P is bigger than Q. So PQ is bigger than Q square is also there. Okay. So wait. 1 second. Oh. One. The 7 has to suggest something. Right? Otherwise, right. So this PQ is bigger than square. It means if I take 4 or 5 or something, then this suggests me to consider P plus 2Q also. Right? And then if we look at this, then it is 4P. Right? So which one is bigger? P square plus 4Q squared PQ, or this thing? So this thing is bigger than P square plus 4PQ plus 3PQ plus Q square. Right? I mean, this is equal to this, sorry. And then this is equal to this. And then this is bigger than P square plus 4. Okay, so meeting will end. I'll just launch again, just join again. Okay.